Thank you for joining us today as we conclude April's Unlock the Value series at our Improving Talks initiative. During this month, Improving's top IT experts have shown us how to maximize tech investments and explore industry-specific solutions that drive real business impact. My name is Armando Lopez, and I am a talent management specialist out of the Improving Mexico enterprise, and I am very thrilled to have you here this fine afternoon. But now, let's talk about the man of the hour, Stephen Anderson. He is an experienced software engineer who specializes in the backend JVM space with focus on the event-driven architectures and real-time data streaming. He also has an extensive background in mathematics and statistics, which drives his interest in using data and analytics to deliver more efficient and higher quality software. Stephen loves biking, going to concerts and baseball games, making cocktails, and hosting movie nights. I am very honored to welcome my friend today with his webinar, Resilient Hybrid Kafka, Automating On-Prem Deployments with Confluent Cloud. But before we start, I encourage you to use the Q&A feature so you can ask him any questions during this session, and he will be answering live. And now I leave you with Stephen Anderson. The microphone is yours, my friend.
Thank you so much, Armando. Appreciate the introduction. And thank you to everyone for joining this webinar today, especially if you're from the north like me. I'm in our Improving Minneapolis office today, and we're finally getting out of winter. So taking your time to view this presentation instead of going for a walk in the sunshine is definitely something I appreciate from our end. But I'd like to get started with kind of who Improving is and what we do. So Improving is a modern digital services company. Like I said, I'm out of our Minneapolis office. This slide is actually out of date as of this week. Last week, we had 18 offices throughout North and South America, but as of this week, we've just welcomed a new enterprise into the Improving family with offices in Pune, India, and Amsterdam. So I'll actually, for my next presentation, hopefully have an updated slide with some more continents to add for you. But needless to say, we've got improvers across the entire world at this point that specialize in all the technologies that you guys are using throughout the enterprise. Here's some numbers. Again, 1,800 improvers, also out of date. We've got some new ones coming in. Our revenue, the scale that we have, the clients that we work with. And here's just kind of a high-level list of service offerings. We definitely specialize across the technology stack. If you need platform engineering, big data, real-time streaming, all those areas of software development, as well as training, community, these webinars, again, across a variety of topics. Improving also likes to focus on working with big partners in technology spaces that are driving value for our various clients. And that's what this series has been about, is highlighting some of those partners. And the partner that I will mostly be talking about today is Confluent, who, as you know, is the pioneer in the Apache Kafka space. We also partner with all of the big cloud providers. You've also seen this in this series talk of Snowflake, Databricks, dbt. We leverage these partners to ensure that we are delivering the best possible solutions for our clients using cutting-edge software and systems with that enterprise-level support. And in this talk, I get to highlight with you a really cool solution that Improving along with Confluent delivered for a very large Fortune 100 client, where we deployed what I'm calling Resilient Hybrid Kafka, where we automated hybrid cloud solution with on-prem deployments, as well as Confluent Cloud, leveraging the cluster linking tool to provide a solution to solve for some pretty complex business needs. So today, I'm going to do a quick overview of event-driven architecture with Confluent. If you've attended any of my talks before, some of this will be familiar. I'm going to go into the specific business need that we had with our client in this case, and then into a lot of details of that resilient hybrid architecture solution that Improving along with Confluent helps to refine and deploy, ultimately successfully meeting those client needs despite the complexity. And then we'll be sure to save some time for Q&A at the end. But as Armando said, if at any point you have a question throughout this presentation, then use the Q&A feature and we'll be sure to address it as we're going. So let's get started. Event-driven architecture. Many of us started in this state. If we've been doing software development for a while, we've got a lot of data producers, a lot of databases. We get these silos. Maybe they're in legacy systems. There's maybe one team that has the understanding of them. There's not good trust between the systems. We don't know what's the quality of the data. Or sometimes there's some blind trust where we just say, oh, well, that's that team's data. We won't do any validation. And as businesses grow, we need data consumers that pull data from across these different silos. And they might be integrating, they might be just reading things, making reports. It starts out kind of simple, it feels manageable. But then you have some more data consumers come online, they're pulling from a different subset of data, and actually they've started producing their own data as well. So you can see with the green database we have there. And then, oh, well, someone is pulling from, now that second level database along with some of the original sources to create a new data set here. And oh, here's maybe some more. We keep growing, more consumers, more redundancy. And ultimately we end up with this complicated web of interconnectivity, point-to-point connections, highly fragile. If a data model changes, just think of the cascading effects. This is not where we want to be. So not that long ago, in came Apache Kafka. I know a lot of us here have probably heard of Apache Kafka, even if we haven't used it. It's been growing in popularity, especially in the last 5 years, really exploded. And the idea was to decouple the data consumers and the data producers with a real-time event streaming solution, a distributed, resilient log of data that could really serve as more of a source of truth. So we can get those data contracts, we can get discoverability. Kafka is extremely high performing, can scale, has good observability and availability, hopefully preventing some of those teams from reinventing the wheel over and over, that point-to-point connection, consuming from that same original database over and over. Instead, those original data sources simply put data into Kafka, and those consumers can pull from Kafka. Seems like the dream, right? Event streaming solves all our problems. But event streaming is not simple. Figuring out scalability, resiliency, those data contracts, discoverability, performance, observability, duplicated efforts across teams, security, upgrades, reconciliation, tech stack. Eventually, all of this stuff starts to catch up with you. And a few moments later, what we thought was our event streaming dream has turned into a bit of a nightmare. Honestly, this doesn't look that different than the first slide. We've got people going from data directly and integrating it with Kafka. We've got unknown sources, unknown consumers. It can be a real mess, especially if you're trying to run that Apache Kafka cluster on your own. So we know event streaming can be easier. Confluent Cloud is here to solve some of these problems. It's fully managed. So that means you're not worrying about Kafka upgrades, things like that. It's global, multi-cloud, 5 nines availability. It has elastic scalability as you grow, enterprise-grade security, support for private connections across cloud. It's got tools like data lineage, the schema registry, the data catalog. It's got a Terraform provider, metrics dashboard. Solves a lot of those things that make things hard. And so we've seen a lot of clients moving towards Confluent Cloud as their product rather than taking on the effort of running a Confluent or Apache Kafka cluster on-prem for themselves. However, there are some situations where on-prem is still valuable and in some cases even necessary. And this is where some really cool tools with Confluent can allow for a hybrid cloud scenario. With cluster linking, you can have that replication between Confluent Cloud and Confluent on-prem and vice versa, allowing for this hybrid architecture. Now you might say, I just said how much work it is to have those on-prem things. Why would we go through all this work? Well, let's get into the business need for our specific client, which again is a Fortune 100 client adjacent to the healthcare space, a very regulated industry, need to keep things safe. So first need was, this was a highly regulated industry. We needed to ensure this data was quality and protected to meet those regulations. The regulation specifically that we were tasked with this project was a new regulation that was passed that required a full chain of custody of their products throughout the distribution process. So that's, going in and out of their warehouses, ultimately getting shipped out to end customers. We needed a full chain of custody recorded that would be provided to the regulator. Virtually no downtime was allowed. So again, this is a massive company. They have a great scale. They are not allowed to operate if they're not meeting that regulatory requirement. So if our system goes down and they're not able to meet that regulatory requirement, their business shuts down. And that's millions of dollars lost per hour, simply not feasible. And as I said, this is a very large company, so the scale was also huge. There would be, millions of events at scale, all of these products moving throughout at every spoke in their graph as they go through the distribution process. We need an event. And so that's a lot of products, a lot of events. We needed something that could scale with that. We also needed a centralized data destination. So if we had all this data in different silos, it's not really the full chain of custody if it's not integrated, right? So we couldn't just have these events recorded and say, oh, at this distribution center, this product was scanned. At this other distribution center, it was scanned again. No, we needed the full path, the full chain through. So a centralized data destination was critical, because that's ultimately what needed to be provided to the regulator. And this, I think, is a business need it should be a business need for every project in the modern day. We needed a reliable and trustworthy data product. And data product is a term that thankfully is getting a lot of buzz right now. I've talked about it with many clients and in many talks. Too often, especially with the ease of event streaming that Confluent provides, there's a lot of times where people say, well, we'll just get the data out there and we'll figure out schemas later, or we'll figure out secure access later. We will, solve these problems. Let's just get the data unlocked. And thankfully, this was a client that understood that from the get-go, we needed a reliable and trustworthy data product so that it could solve the need and be reliable going forward. Not just we squeaked by and made the regulatory requirement, and now we'll go back and fix all that tech debt and get a good product out there. No, we needed that from the start. So this was no small task. And that's why our client sought the advice and help of not only improving, but Confluent, our partner in this project, which ultimately was the source of our success, was being able to work so closely with Confluent and the client to get these needs to really integrate, to all be on the same team, to make sure that we delivered a solution that met these lofty requirements. So I mentioned already, the hybrid architecture solution was our approach. And so we looked to leverage Apache Kafka and Confluent Cloud to serve as kind of the connecting fabric for all of these events across all those distribution centers for those real-time events, for the status and location of products, and use those tools to provide the full redundancy and traceability needed. So what are the key points of this solution? We had Confluent Cloud. That was our central source / destination for the data. So as I said, we needed all of those events in one place ultimately. That's where there could be the integration and provide that full traceability for the regulator. Confluent Cloud is just the obvious solution for that. It's in the cloud, highly scalable, could handle all of our data, and with the great resources like Kafka Connect, Kafka Streams, and now with a lot of the Flink integration, there's a lot of things you can do with your data in Confluent Cloud when that's your data source and destination. But we also relied on On-Prem Confluent Platform, which is the Confluent Enterprise Apache Kafka distribution. And that was deployed on-prem across a large number of the client's distribution centers where these products were actually moving. And for that, we used Confluent for Kubernetes, which I'll say in more detail later why that was chosen and how we used it. But that was crucial for those on-prem Kafka clusters, because as I said at the beginning, running your own Kafka clusters, it's not a simple task. It's something a lot of clients struggle with. And so using this solution from Confluent really made this a lot simpler and easier. The events were ultimately sourced as close to the true source as possible, and that was product scans in these warehouses, in these distribution centers, whether it was an automated scan as a product was going down the conveyor belt, or a manual scan from a worker in those warehouses with a hand scanner, scanning those UPCs. And that's what ultimately triggered at every single scan, which if any of you are working in logistics of things, wholesaling, anything like that, you know how many events that can be. Every single scan ultimately produced an event, and that was a key part of the architecture to meet that requirement. And so we weren't going from a secondary source of some manifest of here's all of the things that were supposed to ship here today, and we'll say, yep, they did. It's truly, it was scanned in the warehouse. That chain of custody is preserved. And I mentioned it already, and it's in the subtitle, but cluster linking was absolutely crucial to the solution. That's another Confluent feature that is only available in Confluent Enterprise, not something that can be done in just base Apache Kafka. And that was used to replicate, in our case, data from on-prem to Confluent Cloud. I'll talk more about cluster linking for later in the presentation, but I will also say right here, cluster linking, it can be on-prem to on-prem, cloud to cloud, cloud to on-prem to cloud, any combination you can imagine. Cluster linking is able to work. It's a very cool tool. Has been available for the last couple of years from Confluent. And if you haven't looked into it and you're using a Confluent Enterprise product with multiple clusters, I can't stress enough. You should look into this. Super valuable, was a key to our solution. And then lastly, for this slide, the schema registry was used for data governance. This is maybe a no-brainer to some of you. If you've been working with Kafka or Confluent, you may say, well, of course we have a schema. Of course we use schema registry. Of course we rely on schema evolution as we make changes to our data product. But frankly, at Improving, we see a lot of clients that are on different steps in their data journey. And all too often, people will start with no schema registry and just rely on those data producers to simply follow a pattern that won't change, and the consumers get locked in as though it's a contract, but there's no real contract. There's no discoverability of that contract. If someone new wants to come in, they don't actually know what the data looks like. They maybe will look at events and see, oh, here's some things here, but schema registry is not something to be thought about later. That's something that at the start, like I said, getting that reliable and trustworthy data product from the outset is so crucial. So we had schema registry from the start with a schema that not only met the amount of data needed for the regulatory requirement of that chain of custody, but also with some thought to the future of what data would be valuable for future business purposes beyond just meeting that regulation, maybe providing data to end consumers, things like that. And so the client was really great at determining the usefulness of their data as the experts. And we relied on schema registry to lock in that good data product and then allow for discoverability for the different end consumers ultimately. So that's some bullet points of what our solution was, but I'd love to show a diagram of what this really kind of looked like with the flow. So as I mentioned, the event source is that product scan. So in this case, we'll say a warehouse worker scans a UPC of a product as they're packaging it up to ship out to a client. So that barcode is scanned. That scanner ends up calling a Java API, and just a pretty simple Java app that knows how to take that data, is able to format it into the correct schema to create an event. So that event is then sent to an on-prem Confluent platform Kafka cluster. So the Java app is running on-prem, it's sending an event to on-prem, all in the same distribution center actually as that product that's actually being scanned. So in real time, as soon as the scan happens, we actually have an event that's recorded into a Kafka topic, which is pretty cool, highly local. Like I said, though, we needed that centralized data solution. So where did that come into play? Well, and that was our cluster link that went to Confluent Cloud. So cluster link, again, connects from the on-prem cluster to Confluent Cloud, actually does a byte-for-byte replication of the on-prem topic into what's called a mirror topic in Confluent Cloud. So then once the data is centralized in Confluent Cloud, that's where the ERP system can consume those events, integrate the data across the different distribution centers, do some massaging, create the reports and the real-time solutions for the regulator, while also doing some amount of analytics and ultimately even exposing data to customers. So this is the kind of flow of a product through the eventing process all the way to Confluent Cloud. Full disclosure, the system was a bit more complicated than this. That Java app actually talked to Confluent Cloud, and there was even a local document database in that same on-premises deployment that stored some kind of global metadata that would basically be cached to enrich some of the data that came from that product scan. And that was a cool way to have the Java app connecting not only to the on-prem cluster that we set up, but also to the cloud cluster in Confluent Cloud to get some of that centralized data. And you can just see how there's a lot of versatility with this type of setup. There are a lot of options. We actually could have even cluster linked from Confluent Cloud back to on-prem and had the Java app consumed from on-prem, but the importance of this data was not so great that we needed that on-prem duplicate. We just needed to have that cache in our document database. So that's not exactly that piece of it isn't exactly the focus of this talk, but it's still cool to see the interconnectivity and the amount of versatility that you can get out of this hybrid solution. So you maybe looked at that diagram and I tried to make it look simple and pretty with a flow, but you might look at that and say, why hybrid? Why do we have that on-prem and Confluent Cloud solution? a big piece of this is that zero downtime of the distribution center. So our regulators said that if that data was not being recorded, that distribution center would not be allowed to operate. So if those events aren't happening from that product scan, we couldn't, reconcile later. We would have to pause the lines in that warehouse. That's, again, millions of dollars lost. Truly just unacceptable. And frankly, in the just-in-time world that we live in with logistics, the ripple effects to customers and their customers, it's just simply too great for us to tolerate even a couple of hours of downtime. So this hybrid solution was highly tolerant to connectivity failure. We are all aware of cloud outages. They're thankfully rare, but when they happen, boy, do they make the news. If an AWS region goes down, if GCP or Azure have issues, that's newsworthy because that disrupts so much of every industry at this point. But even at a lower level, we don't need a whole cloud region to go down. What if a fiber line is cut to this distribution center? We don't want to be reliant entirely on an internet connection to our cloud solution. And so actually in this scenario, since our events were still being recorded in that local cluster, we'd be able to keep the distribution center rolling even in that unlikely event. And again, the cost of going down with the distribution center was so high that it's worth the complexity of this hybrid architecture. It also has the added benefit of resilient data across on-prem and cloud. So like I mentioned, Confluent Cloud, highly reliable product built on to operate on the major cloud providers, whatever you're currently using in your enterprise, it's able to work. Also, there's bring your own cloud options, highly resilient. You get that 5 nines uptime. But also, Kafka itself is just a resilient tool. If you look into the details more, you know how it is it's a distributed log of data that's across multiple brokers. There's replication. You're able to do tuning and configuration for the amount of tolerance you have for, how many replicas are needed, how many replicas must be in place before an event is considered acknowledged and truly committed. All these things provide that resilient data across on-prem and the cloud tool, giving us high redundancy, which is frankly what we need when it's a regulatory thing. This is, these are laws here. The cost of not meeting a regulation is just as high as the cost of shutting down a distribution center. This also created a self-sufficient distribution centers with a consistent deployment pattern. So that makes the distribution centers truly independent, as I was mentioning, but also consistent with each other, which is super helpful when you're having to scale across multiple distribution centers. So I want to speak to some of that consistency with our solution. The client had been able to get a deployment of their on-prem setup in a single test distribution center, and it took them about a month. And so this was before we were brought in with Improving in Confluent to help make this more efficient and solve some of the architectural problems. We had, I'll spoil it now, 30 distribution centers that ultimately had to be deployed to. It simply could not take a month to deploy everyone and get it working. Even if it's just the first time, that would not have been sufficient amount of time to meet the deadline for the regulatory requirement. But also, even if that was cut down drastically for subsequent deployments, if there were upgrades, things like that, it just couldn't be manual. It simply was not workable. It needed to be automated. So we, from Improving, worked with the client to build what we call the distribution center template deployment. And so that's that Confluent Kafka on-prem, that document database, and the Java app. That was all deployed to a local Kubernetes cluster. And there were other teams and partners working out to build that hardware to host the local Kubernetes cluster. It was truly an impressive effort across so many teams. And it was really cool to work with the client and be a part of such a big solution for them. But on the Improving side, again, we really focused on how do we automate this deployment? How do we make the complicated pieces simple? So I mentioned how it's complicated to deploy Kafka, to manage Kafka. And there's also a Java app and then another database on top, all local. So a lot of work was centered around making that template. Once we had that template, we were able to deploy that template in a repeatable manner to every distribution center, 1 to N, in our case, was 30. And so that was kind of the first step of how do we get that? So getting that repeatable deployment process applied to all the distribution centers. A key part of that solution was Confluent for Kubernetes. So I said I would talk about this more. Confluent for Kubernetes is a Confluent-provided Kubernetes operator. So if you have experience working in Kubernetes with operators, you know how powerful they can be, and it really takes away a lot of the complexity and offloads it to allow you to just provide some pretty simple configs through declarative YAML that allowed us to create, the Kafka clusters, which at the time we were deploying this still required Zookeeper. Confluent now and Apache Kafka have finally really gotten to the general availability of Kafka clusters without Zookeeper, which is fantastic, simplifies things rather than two distributed systems that you have to manage. We're down to just one, and it's all the Apache Kafka broker. We love having the simplicity and also the dog fooding of relying on the broker to do these things. But at this point, we still needed Zookeeper. Confluent for Kubernetes handled that and the config there, but also does some really cool things like the actual topics. It'd be one thing, sure, the operator makes all of these, it makes the actual brokers, makes Zookeeper, makes the different deployments that we need. But if we had to go in and manually create a topic or have a script to make a topic every time, that would also be pretty tedious. The Confluent for Kubernetes operator can do that, can make the topics, made the schemas, and it also even made those cluster links to Confluent Cloud. So all of that was done through declarative YAML config that Confluent for Kubernetes interpreted to actually facilitate the deployment. That makes it highly repeatable. There were minor differences in that config, basically, topic names and things like that were all very, very easy to just variabilize for the different deployments. If you have not looked into Confluent for Kubernetes and you're still needing on-prem for the many reasons that all of us need on-prem deployment still, the cloud may be everyone's first choice now, but it's certainly not the only option and not always the correct option. But if you're doing anything with Confluent platform, trying to deploy to Kubernetes, especially Confluent for Kubernetes is an incredible tool. And it also has additional features for scaling and self-healing, things that you can look into. Makes things like Kafka upgrades very easy. Definitely a powerful tool. So this allows for also GitOps friendly deployments. GitOps is another one of those fun platform tools or terms that we are frequently excited about in the engineering space, but truly allowing our infrastructure as code in this case to truly be reflected immediately. Of if you change your config in code, the operator can accept that and immediately make that deployment reality. Very powerful, highly simplifies a highly complicated thing of Kubernetes deployments. As again, I assume many people here have worked with Kubernetes, and you know that it's certainly not simple. So making not only Kafka and Confluent simple, but Kubernetes simple in this scenario is no small feat. And lastly, it allowed us to standardize some Kafka cluster config. If you've worked at all with Kafka clusters, you know the number of properties and things that are set. If I had to be doing it 30 times and you said set them every cluster up exactly the same, as a human, odds are I'd be missing one of those properties somewhere in there. But in our case, we needed that standardized config. Those configurations that we had for our Kafka brokers and the different pieces, they needed to be consistent, and Confluent for Kubernetes made that easy. And so that was a huge part of creating that distribution center deployment template. So the next step, repeatable across all of those distribution centers. That was that standardized config that allowed that template, as I was saying. So the next step was we've got that template for the distribution centers. How do we link that to Confluent Cloud? As I said, that's our centralized data source. That's where we're looking for our integration points. And this is where cluster linking from on-prem, in this case, Confluent platform, to Confluent Cloud was integral. So each of those distribution centers had their own specifically named topic for the events that were coming in, those product events within their distribution center. And each of those topics was linked to Confluent Cloud, where a mirror topic was created there. So the end result is 30 mirror topics from all across the different distribution centers that all get linked byte for byte replicated into Confluent Cloud. So cluster linking was a huge part of our solution. So I definitely want to go into a little more detail of what cluster linking is. If you haven't used it, again, it's certainly not brand new, but it's one of the newer Confluent features. So not everyone has experience with it. You've maybe been used to using some of the older tools like Mirror Maker or trying to use Flink, Kafka streams, things like that to replicate data across clusters. Or maybe currently you are in a situation where you only have a single Kafka cluster, but you want to be able to have multiple clusters, do those links and replications across. And that is something that is achievable with cluster linking. So cluster linking is a native Confluent feature. So again, this is only in Confluent Enterprise. It's not in base Apache Kafka, the open source. So you will need Confluent for this. But it's a native feature in that there's not a second deployment. It's not like Kafka Connect or ksqlDB, other tools where you're deploying more actual instances out into your environment to have this tool. This is built in to the Confluent Platform broker, which is very cool. And so that's on the cloud side and the on-prem side. Yes.
We've got one question through the Q&A feature from
Oh,
Lata Kutik. It says, is this template in Terraform? What is a tool for Confluent Kubernetes deployment?
Oh, so this is something that I actually would have liked while we were on the project to get further along with our deployment strategy and using Terraform. There was Terraform used to create the Confluent Cloud deployment using the Confluent provider. For our template, we actually were relying on just GitHub Actions running some different shell commands to actually apply the custom resource definitions, those YAML for the different Confluent pieces, as well as the Java deployment and things. So that's something that I think, given time, there could be some enhancements and expansion there, but kind of started with the simplest approach of just scripting it. So not as exciting of an answer as Terraform, but certainly works to get our solution out there. And so a part of this deployment was these cluster links. And again, so that's a part of the YAML definition, that there's a custom resource definition within CFK for cluster links. Very cool. I do want to emphasize also, so again, there's not another pod that needs to be deployed. There's not a connect piece. This is actually using the Confluent Kafka brokers. So it's already built into your cluster if you're using Confluent Enterprise. And the resource definition is truly just setting up that connection between the clusters and allows for true byte-for-byte replication. So that's seamless. That's offsets, partitions, timestamps, etc. It's mirrored. It's not copied. It's not, oh, if you don't have a key, then ordering doesn't matter, but oh, ordering would be in different messages, could go to different partitions if you're using something like Kafka Connect to just push data out there. And then if you ever needed to fail over with a consumer, then the offsets would be different. Things would be in different partitions. There'd be duplicates. Not with cluster linking. It's truly a byte for byte copy. That is a powerful tool. So again, configured through CFK, and it catches up in the event of a connection loss. So I mentioned part of our resilience that we needed was having the ability for a distribution center to keep going, even in the event of losing internet connectivity, can't connect to Confluent Cloud for any reason. We were able to still store those events locally in a resilient, replicated way. But ultimately, we do still need it in that central data source. As soon as the connection is restored, because it's byte-for-byte replication, Confluent Cloud knows exactly where it left off, and it's able to catch up in all those messages. There is a replication lag metric that you can view in Confluent Cloud to see, how long is it taking to catch up. And there's also tuning within cluster links and similar tuning to the brokers, where you can give an amount, a percentage of resources that can go to replicating data amongst brokers. You can also give a percentage of resources that you're willing to give to replicating through cluster links. So in the event of an outage, it's also possible to tweak that setting, maybe give a little bit more resources to catch up. But frankly, it's a pretty fast solution, and Confluent Cloud is able to catch up very quickly. So this is our full solution, kind of each of those pieces. We've got our different distribution centers, cluster linking to the Confluent Cloud. The ERP system is able to take that centralized data, do work on it, go back and forth with Confluent Cloud of new topics, of normalized data, integrated data, different things like that, and then ultimately have a reliable, trustworthy data source for not just the regulator, but once that data is unlocked, once it's out there, it can be provided to the end customers. So they maybe don't need to see the full chain of custody, but they maybe want to see, when and where was a product shipped out and what was the distribution center that it was shipped out from to get a different idea. Maybe they need to return some products and they need to know, oh, is this, from this order or a different order? All of that data is now available for customers as well. So that's a common story amongst people that use event-driven architectures where this data has been locked up, it's been in silos, or maybe it wasn't even being collected, like in this case. And you might have a single business need. That regulation, we absolutely needed to meet that regulation. But once the data is out there, we can keep finding more solutions for it. And also in the future, also do things like analytics, maybe integrate Snowflake using some cool Confluent features like table flow to be able to maybe learn some different things of, do we have distribution centers that are over or underutilized, things like that. Once that data is out there, the client is now able to do even more with it, find more power than just meeting that regulatory requirement. So let's go back to our business need and make sure our solution delivered what we needed it to deliver. So did it satisfy our regulatory requirement? Absolutely. We got the full chain of custody of products. Those events were recorded as soon as the product was scanned, super real time. And then we had a hybrid architecture that prevented downtime, allowed those distribution centers to run independently and not be reliant on outside connectivity to be able to keep moving, but still be storing those events in a reliable way. We used Confluent Cloud and CFK to deliver the scalability that we needed for the millions of events, as Kafka is a tool that's able to do that. And then also having that cloud centralized data that was the single source of truth for the ERP system and ultimately what could send data to the regulator. And I can't punch this enough. Schema registry was there to enforce the governance of the data, to make sure that we had a reliable data product that would last for the long term. And so ultimately, I won't say that this was a simple solution, and it won't make sense for every use case, every client, every industry. But in our scenario, this hybrid Kafka solution with on-prem and cloud was able to satisfy the needs of the client, went live, and was successful thanks to the great work from Confluent, improving, and our client all working together to deliver this ambitious solution, which I hope you guys found interesting, and maybe we'll have some thoughts of different tools you can use going forward. So with that, I wanted to make sure to leave time for questions, and I'm glad we did. So if there are any more questions that are through the Q&A, Armando, would love to talk more about this architecture and do my best to help illuminate it more.
Thank you, my friend. And yeah, we're receiving a couple of anonymous questions through Teams. And the first one says, why manage all the on-prem clusters as opposed to using Confluent Cloud directly?
So this is a fair question. And I tried to kind of show the need for the independence of those distribution centers. I will say the downtime again would be millions of dollars, and not following the regulatory requirement is also millions of dollars in fines. So we really needed that data to be able to be collected and flow, even if there was no network connectivity. And you might say that's rare. How often does that happen? And that's fair. The client did a risk analysis and decided it was worth the effort and expense to have these multiple deployments. And that's why we did our best to try to simplify those deployments. The client really felt strongly that that's what was needed. And we wanted to make it as achievable for them as possible. And allowing those on-prem deployments to go in isolation was key. I'll say also, if there was an issue with things with the on-prem cluster, they were also able to fail over to go directly to Confluent Cloud. So that was a valuable piece also. We certainly didn't want to pretend only Confluent Cloud could go down, only Azure or network connectivity could go down. It's true that there could have been problems on-prem. And so, yeah, the ability to fail over to a cloud deployment of the Java app and Confluent Cloud was also there. So we had full redundancy there.
Okay, thank you. And the next one says, what are the benefits and drawbacks to cluster linking as opposed to Mirror Maker?
This is a great question. Mirror Maker's been around for a long time, so there's a lot of familiarity with that tool. Mirror Maker was kind of the first stab of cluster replication, cross-cluster replication of data in Apache Kafka and Confluent. It relies on Kafka Connect under the covers, which requires another deployment. You need the Confluent connect brokers out there, basically, in addition to the base Kafka brokers. So that adds complexity to your deployment. And then also, while MirrorMaker has gotten better and it's powerful, it does not have those same tools for byte-for-byte replication. So copying those offsets and timestamps is really huge for cluster linking. It's truly trivial to fail over a consumer in that scenario because even the offsets are replicated, which is really, really different than MirrorMaker, where you would have, the same topic potentially, but as things are copied, offsets won't be exactly the same. If you have keys, they'll still be ordered within those keys, but you could still get duplicates. If you don't have keys, then with round robin or whatever, things will end up in different partitions. It can be very hard to determine where you need to start consuming if you're doing a failover. So cluster linking is definitely the tool to use at this point if you are working with Confluent.
Interesting. And the last one we have received comes from Improving Mexico, and it says, "How did you handle CID for the that many CFK deployments?"
Yes, I alluded to this earlier with the previous question, but GitHub Actions was our tool in this case for performing these different deployments. GitHub was the environment that the client was already working in. There was comfort there. So we built out custom GitHub Actions workflows for deployments for different environments. And we templatized using our different scripts within those GitHub Action workflows so that the developers on the client side were able to go in to our deployment repo, select the distribution center, select versions of the apps, do those upgrades and different things, and ultimately do an automated deployment through GitHub Actions. That is something that, again, I think could be enhanced. We didn't get to a full, true GitOps model where there could just be a commit for an updated config in that YAML, and it would automatically go through and deploy to the different distribution centers. But we were able to get it to the viable products to meet the regulation, and the client had the understanding and hopefully grow in their deployment model going forward.
Such a rock star, Stephen. You've answered all of our questions, and that's it. I don't know if you have any closing remarks before we say goodbye to the audience.
I guess I realized one more fun piece of trivia about this specific architecture, again, and the importance of working with a partner like Confluent, who is there and available, is our cluster linking solution resulted in 30 different cluster links. So that's 30 clusters all linking to a single Confluent Cloud instance, which at the time was a record for Confluent. And if you were to start your own cluster links in a Confluent Cloud cluster, at least at the time, they've maybe upped it now after testing with us and this client, the quota was 5 links. And so this is a really cool thing to be able to kind of have that record of doing 6 times as many clusters linked together, and working with Confluent to ensure that there was full reliability there was a really cool part of the project. And I'm clearly passionate about the cluster linking feature and how much it solved for us. So I just like to have that as another piece of why working with Improving and the partnerships that we have can provide so much value to do things that truly no one else has, which is really cool. Thank you guys for sticking with me for this past hour through this presentation. Again, I really hope that you took something away from it, and feel free to, connect with me on LinkedIn or anything if there are future questions. And if you have any possible projects or things that you're looking to get questions answered about what an event-driven architecture would look like, bringing in something like Confluent, no matter where you are on your data journey, as you've learned through these talks, Improving and our partners are there to help you. So definitely reach out with any questions. And thank you all again.
There you go. Talk about closing this series with a bang, Stephen. I want to thank you all for joining us today, but especially you, Stephen Anderson, for sharing this presentation with all of us. It was a really nice work. It's been a pleasure being a part of the Unlock the Value month at Improving Talks. Great content all around from our experts. And coming up next week, come join us for a brand new series with our AI month, starting with Devlin Lyles, CCO and President at Improving, with his session, Architecting for AI Success.